Welcome back, students. Today we're going to talk about our other senses. Our other senses. So the first senses we're going to talk about are our chemical senses. Taste, which is known as gustation, and smell, which is known as olfaction. So what makes these senses different from sound and sight, like we've already talked about? Olfaction, or our sense of smell. We have 5 million receptors to sense smell, which seems like a lot, but that's nowhere near the number of olfactory receptors that dogs have, for example. Smell is the only sense that actually avoids our thalamus in the middle of the brain. It's actually processed in the brain really close to the limbic system, which, if you remember, is where the amygdala and the hippocampus are located. Which is why when we smell very pleasant smells or very unpleasant smells, we have a very visceral, sort of strong reaction, and it can trigger memories, which is kind of cool. So essentially what happens in order for us to smell something is that there are tiny particles floating around in the air. Those particles go up our nose and are trapped in sort of the mucus, which is located up in up in your nose, and in the hair follicles as well. And the hair follicles and the mucus also sort of filter out things that we don't want going up into our brain. And so then that smell actually goes, those particles go to the olfactory bulb to be processed. The olfactory bulb then sends that information via the olfactory tract to the limbic system. And that's really all I want you to know for this. We're not going to go as in depth with the anatomy of smell as we did with with vision and audition. Another way of thinking of it or visualizing it is you have these little particles. They stimulate the olfactory bulb, which goes to the olfactory tract off to the brain. Gustation. So gustation is our sense of taste, and our tongue actually has receptors for 5 different types of tastes. And they believe from an evolutionary standpoint that they have survival benefits or survival reasons why we taste specific things. So sweet tastes were likely an energy source. And in nature, sweet tastes are very rare. And so our brain sort of developed in order to crave sweet things and eat as much of the sweet stuff as we can, because it was scarce for most of our species' existence. Now, sugar is all around us, sweetness is all around us, which makes it difficult to not want sugar or crave sugar. Sour. The reason why we have sour, the ability to taste sour things, is because it was potentially toxic. And that's kind of similar with bitter things. Bitter things tend to indicate poison. And so we have strong reactions to bitter things because, well, you don't want to keep trying to eat poisonous things because you get sick and then you vomit and then you're not absorbing nutrients. And so we have to learn over time that bitter things are not poison, which is why it's difficult in children for to eat bitter things like vegetables, for example, or coffee. Salty or sodium, we need that for muscle growth and for hydration. So we can usually get a lot of the salt from meat. And then the last one, which is the most recently discovered taste, is umami. Was discovered in Japan. It's a fancy way of saying like savoriness. So the best way to describe umami would be if you've ever had something like a real juicy steak or some really good chicken. It's like that sort of like I don't know, savory. It's like fatty. It's good, like something that's buttery, or like if you don't eat meat, like, if you get like something with a lot of oil in it or something like that. So on our tongues, you may have looked at your tongue and been like, oh, those are my taste buds. Actually, those are not your taste buds. Your taste bud, those are the papillae. It's the top of your taste bud. So your taste buds look kind of like mushrooms. So what you see when you look at your tongue is the tops of the mushrooms, but that's not actually where we taste. They serve to protect the taste buds, which are actually located in the stalk. You actually have cilia, like you do in your ear. I mean, there are different type of cilia which detect different tastes. So we're going to watch a brief video about this because some people actually have way more taste buds than others, and they're known as super tasters. Sensory interaction. So our different senses influence each other. The most common example of this is that when we talk about flavor, flavor is an experience, not a taste. It's an experience of smell, temperature, and texture. So this is often why, so our sense of smell and our sense of taste, it interacts with each other, or olfaction and gustation, they interact. So if you've ever, you had to eat something that you didn't really like, well, what you tended to do was hold your nose, and then you could eat it and you wouldn't quite get as much of the flavor of that thing. So, and I think it's important to note that all of our senses are constantly interacting with each other. So vision is our most dominant sense, unless you're blind, in which case vision's not your most dominant sense. So all these senses are sort of interacting with each other. Our sense of touch. So we have different receptors in our skin, and those receptors are detecting pressure, temperature, and pain. I think it's important to note now, because you were probably wondering, well, where does spicy fall under the whole taste thing? Spicy is not a taste, and it's not a flavor. Spicy is actually pain. When we talk about spicy things like a hot pepper, a jalapeno, or something like that, or a habanero, those plants developed as a survival mechanism, a defense mechanism, a special enzyme called capsaicin. And when capsaicin is oil-based, when you ingest capsaicin, it coats the tongue in this oil, which tricks the nervous system into thinking that it's on fire. And that fire burning feeling is painful. Now, most other animals will just be like, okay, I ate the fire pepper, I'm not going to eat that again. But not humans. We realize, we're able to think through and realize, okay, the thing didn't kill me, I'm going to eat it again. Sometimes I wonder if this is a good thing or a bad thing, although I love spicy stuff. So, biopsychosocial influences on pain. So basically there are biological influences, meaning like our genetic differences in how much endorphins our body produces. Remember, as a reminder, endorphins are your body's natural painkiller. There's psychological influences, so like how we learned to experience pain, whether we were supposed to not show pain or in order to be tough, or whether we were expected to do that. And then sociocultural influences on pain. So other people are around, depending on who those other people, you might have more pain or less pain. There's also cultural expectations for how pain works. So for example, a rite of passage in, there's a few rare tribes that in order to pass from boyhood to manhood, they actually take hooks, and they take them and they hook the person's skin in their back in specific parts, and they suspend them in midair. And then it varies across different cultures as to how long you do this. But if the person cries out or asks to come down, they can never be considered a man. They will be considered a boy for the rest of their lives. Gate control theory of pain. So we have different gates located in our spinal cord that can either block pain or allow it to be sensed. And so if you've ever wondered, well, why is it that when something hurts, like I have pain in my neck or back pain, if somebody presses on that, it somehow lessens how much it hurts? That's because you're sending competing pressure signals through that gate, and the gate can only allow one signal through. So this explains, like, the first thing we do when we skin our knee is we're like, oh, and we like go to rub it. Or like sometimes when you have a headache, you might push on your temples, or you might squeeze right here. It doesn't make the pain go away, but it lessens the feeling of pain as well. Our other senses that we're going to discuss are body position and movement. So our sense of body's position in relation to itself is known as kinesthesis. So this is an additional sense for you. The kinesthetic sense is basically knowing where your limbs are in 3 dimensions. So like if you close your eyes, so go ahead and close your eyes right now. Now lift your arm up. Now touch your nose. So you were able to do that because you know where your nose is and you know where your arm is in relation to your nose without looking at it, which is a really, I mean, it seems like this is sort of an obvious thing, but there are cases, and you can find videos of this on, on the internet, where people lose their kinesthetic sense. And the first thing that happens is they can't walk because if they're not looking at their limbs, they don't know where their limbs are at, and then they just crumble. And so they can gradually learn strategies in order to overcome this condition. But they said one of the videos I watched, the guy was talking about the most difficult thing was learning how to go to the bathroom by himself. Because if you think about it, like, and specifically, I know this is kind of gross, but thinking about how to clean yourself so you can kind of like just wipe without having to look, which is when you don't know where your hand is in relation to your body, you're not able to do that, which is kind of unique and interesting, also kind of gross. Also, like dribbling a basketball is a great example of your kinesthetic sense, because eventually when you get good enough at it, you know where your hand is and you know where your ball is in relation to that. And so you don't have to constantly be looking at the ball in order to dribble. Your vestibular sense, on the other hand, is your body's sense of balance, basically. The vestibular sense is related to gravity. And just above the cochlea in the inner ear, we have what are called semicircular canals. They're also fluid-filled, and they have tiny hairs in them. But the movement inside of the semicircular canals tells us whether we're in motion or not in motion, which is kind of cool. And that, ladies and gentlemen, is all I have for you today. If you have any questions, let me know. Otherwise, have a fantastic day.